Friday, the last science lesson. And then school resumes as normal and we're back to doing science in the classroom. So we're continuing our investigation into alternate energy sources, and we're investigating today how sugarcane can be used as an energy source. There's a lot of sugarcane in Queensland, and therefore, after the sugar is extracted, there's a lot of left over from the plant material. So we'll be investigating that in the video shortly. First of all, let's quickly revise. I want you to list some of the types of waste materials that we've heard about yesterday that can be used as an energy source. So pause the video and jot down some of your ideas there, just to revise. Are these some of the ones you wrote down? There's definitely agricultural waste, food scraps, paper, production waste, crop waste, livestock manure, food, scraps and sewage. All can be used as an energy source to generate electricity. All right, let's have a look in particular about the sugarcane industry. So this is the site that it's come from, and I've just recorded it for you to make life easier.
In the sugar industry, cane trash has long been burnt to generate power to run the mills. But now scientists are finding new uses for it, including transforming the trash into animal feed. Courtney Wilson with this report. The business of producing sugar takes and makes a whole lot of energy.
We're budgeting to crush this year 1.5 million tonne of cane over a 25-week period, and typically on a daily basis we're processing around 11,000 tonne a day.
Like many mills around the country, Mackay Sugar in central Queensland runs on a motto of waste not, want not. The factory is powered predominantly by burning bagasse, a byproduct of processing cane.
Once the cane arrives at the mill, we go through a process where it is shredded and it's prepared cane. It goes through a series of mills, and after processing through the mills, it comes out of the final mill is what we call bagasse.
% of the cane juice or sugar is extracted at the first mill. What gets spat out is essentially fibre. That fibre then goes through 5 other mills where it's repeatedly processed. By the time it goes through the last mill, 96 to 97% of the juice has been taken out. At that point, what's left is bagasse. And even though it's a byproduct, it's still really valuable.
It's what we call in the industry renewable energy. It's a green energy where rather than burning fossil fuels, we take the opportunity to burn that in our boilers to generate power, steam, which powers our turbines and our process, and export power into the grid. The power that we generate here, our maximum export level is around 28 megawatts, and typically that's supplying power out into the grid, which would supply or supplement in running probably a third of the power requirements of Mackay City.
But scientists want to know if bagasse could be put to another good use. They're experimenting with turning it into fodder for livestock.
If we want to increase our animal production capacity here in Australia, we need to think very carefully about what we're feeding those animals. We need to look to residues and byproducts from agricultural systems that are available at central locations like sugar mills as potential feed additives, as potential feed ingredients.
This is the Mackay Renewable Biocommodities Pilot Plant, aka a scientist's dream. Dr. Mark Harrison from Queensland University of Technology in Brisbane is here working on turning what's not needed to make sugar into valuable animal feed. So what are we looking at here? This is what you're after, essentially.
That's right. So this is sugarcane bagasse. So this is the byproduct that's left over after billeted sugarcane comes into the factory and goes through the shredder and been through the mill train. What's left over is bagasse.
But this isn't trash. It's a byproduct, but it is valuable.
Absolutely. This is burned in the boiler in the factory, and it provides process heat and steam and electricity. And in some mills, it provides quite a valuable source of income. So no, it isn't a waste. It isn't trash. It's quite valuable.
This plant is on the same site as the Mackay Sugar Factory. It's funded by the Commonwealth Government and Sugar Research Australia as part of the Rural Research and Development for Profit program. The whole point is to deliver actual outcomes for producers. In this case, breaking down bagasse to hopefully feed animals, to in turn feed a growing global population of meat eaters.
Our global population is expanding, and Australia is really, really well placed to supply animal products to the world. But to do that, we need more feed.
To turn bagasse into something nutritionally beneficial for livestock, like cattle, pigs and poultry, it needs to be made more digestible. Scientists are using elevated heat to break apart the bagasse so the sugars it contains are more accessible for the animal that's eventually going to eat it.
So this is the steam explosion gun. So this sits below our horizontal reactor upstairs. And so we can take pre-treated fibre, drop it down into this reactor. We can put it under high pressure and high temperature for a short period of time. And then we release that pressure and the particles, the fibre explodes and breaks open.
It's a pretty high-tech process, using technology similar to that of a masonite gun, which is used to make fabricated wood products.
So this is what bagasse looks like after a particular type of pre-treatment, after steam explosion, and you can see how the structure of the fibres changed. The fibres have gotten a lot softer, and we've partially dissolved some of the components in the fibre. And so this material, if that was fed to an animal, that animal would get much more energy out of that fibre than they would get out of raw bagasse.
If that seems like a whole lot of work to make something that'll just be fed to chickens and cows, well, it is. But that's because there's potential for huge benefits for livestock producers, the sugar industry, growers, and beyond.
We have expanding markets that are relatively close by, so we really do need to understand the ways in which we can get the best out of the production systems that we have here in Australia.
Joe Muscat is a lifelong cane grower from Oakenden, about 30 kilometres southwest of Mackay. Between Joe and his son Stephen's nearby farm, the family grow about 25,000 tonne of cane every year. But he's not solely a sugar man. Joe is passionate about diversification.
I think, we're at a stage in this industry where we need to seriously look at the economics around the business. And, being able to rely on one commodity right through is pretty hard. 85% of what we produce in sugar goes into the world market, and that's a very volatile market.
There are plenty of bigger players in the sugar industry, like Brazil and India, producing far more than Australia. And the price fluctuates depending on global sugar production and the demand for it. So sometimes, when the price is low, cane growers know at the outset of planting that when the season comes to an end, they probably won't even cover costs. Joe Muscat says it's not viable and it's forcing growers to find second jobs to survive.
I think in the central region, we're probably looking at about 75% of farmers working off-farm to make their business stack up.
He believes there must be a better solution than farmers leaving their farms to make ends meet.
There's nowhere near enough work being done on how we add value to our commodity or how we add value to the business that we're in. And I really think we're in an era that we really need to get this right. It's something that will prop this industry up into the future. And it's not really rocket science. I think if we look around us in the sugar industry business, there are plenty other regions and countries, adding value by adding different product lines to their business.
In South America, for example, one of the big mills has the ability to go from producing about 70% raw sugar and 30% ethanol to the other way around. So if the sugar price crashes, they can instead opt to produce about 70% ethanol and know they'll fetch more money.
What it did do well was help the factory be sustainable. So the grower knew that no matter what was happening, they had a processing plant or the milling there to actually, crush their product. And here, that's one of the threats we've got. Like if our milling is not sustainable, the production system falls by the wayside because they're a joint partnership.
A staggering amount of debt has caused plenty of woe for Mackay sugar contracted growers. And although Joe is buoyed by the research into using bagasse for animal feed, he wants the industry to invest and do more in the way of value adding.
Our input costs are always increasing, electricity, water, fuel, insurances, all those aspects of the business are always increasing. So we've got to find ways to manage that and to, be able to keep a profitable business happening. And I see, value adding as the opportunity that we've got going forward.
The business of trying to turn bagasse into animal feed is a great step in that direction. But there's still a lot of work to be done before it can become a reality. At QUT's Brisbane labs, Dr. Robert Spate leads a team working to further improve the nutrition qualities of bagasse using probiotics.
Something like a sugarcane bagasse feed, this fibrous feed, can still be challenging to digest and get all those nutrients out. So if you just feed that to an animal, they won't grow as quickly as they might do, or you might want them to do. So what we want to do is to add the probiotics or enzyme supplements into that so that they start to grow at a faster rate. So that means they're more productive animals for the farmer, more profitable.
So Rob, what's actually happening here in the lab?
Yeah, so this is how we produce the probiotics on a slightly bigger scale so we can make enough to go into some of our initial livestock feeding trials. So we've actually got these going into chickens in the next couple of weeks.
The scientists have looked at raw bagasse and what organisms already grow in it naturally and used that information to develop probiotics to help make the bagasse more nutritious.
It's these new technologies that are going to make the difference in the end. So it's about protecting the industry, it's about future-proofing the industry.
There's also the added benefit of bringing more professional employment to places like Mackay and other sugar-producing cities.
This will be high-tech manufacturing in the regions using fermentation-type technologies and the best of biotechnology, coupled with the agriculture industry, which is already so strong in Queensland.
Large-scale trials of the bagasse-based animal feed are the next big goal. There's still plenty of hard work ahead, but scientists and stakeholders are hopeful of making it happen sooner rather than later.
We've got real opportunities for the ag sector in Australia. We have opportunities because of the available land that we have a strong record of innovation here in Australia, in agriculture particularly.
If we're going to look 50 years down the track, I think that's got to be part of the sugar business. If it's not, I think we'll see a very different sugar business to what we've got today.
Okay, that was a long video, I know. There's actually quite a lot in there. Very much I guess, covering not only the sugar industry, but a lot of our farming industries in general, because the things that our farmers have to do are changing. They're competing on the world market, and you're probably learning that about, or learning about that in geography and so forth. But to compete on the world market with a changing industry, um, science and innovation has to come very much into it. All right, let's have a look here at the questions you need to answer. So that word that they were saying, bagasse, is spelled B-A-G-A-S-S-E, and you have to tell me what it is, what it's used for. Now, there are a couple of uses that they talked about in there. If you focus on question C and the benefits of it, then tie it in, make sure you tie it into all that idea of renewable and also sustainable. And similar to the previous video, there's a statement there which you have to say whether it's true or false. Okay, so pause the video and see if you can answer those questions now. All right, what is bagasse? Bagasse is the fibrous pulp that is processed into a usable form after sugarcane has been squeezed of its juice. So if you just said something like it's the leftover after sugarcane or the pulp of the sugarcane, you're pretty much on the right track. What's it used for? All right, currently it's used to produce heat and electricity in sugar mills, but they're starting to explore how it can be used as a food source for farm animals. If you said that, good on you. I'm happy with that answer. What are the benefits? Well, it's a natural byproduct. So it doesn't take a lot of energy to repurpose. Now, repurpose means to find a new use for it. And they're looking to repurpose it as an animal food. Now, it's also readily available every year because the sugar industry goes through that regular cycle of a sugarcane season where they cut and then produce the sugar. And so it's every year that occurs, and therefore it's environmentally sustainable. And then the last question, bagasse is not a renewable energy source, true or false? Well, that's false. And here's the reason why. It is renewable because it's harvested every year on a yearly basis, so there will always be sugarcane waste that can be turned into bagasse. That's it, done, dusted. We've learned about a whole lot of things to do with alternate energy sources. And so from next week, you're back in class, and I look forward to seeing you there. All right, thanks, guys. We'll catch you then.